Adam Muzzin. 20 years, man.
Yes.
Professor of astronomy at URQ.
Indeed.
And you and I go way back. U of T. This is what, 1998?
Yes.
And you managed to do something which was, I think, really, really cool. You followed through with a whole bunch of things that I never dared, which was you became an academic, and now you're doing some awesome stuff. So what are you up to these days?
What am I up to these days? So lots of stuff. I think the thing that people find really exciting is so I study galaxy formation, trying to figure out how galaxies got here in the first place. And for your listeners, I don't know how much everybody knows about galaxies, but we live in a galaxy, which is the Milky Way. And you can go out and see it. It's filled with like 100 billion stars, of which our sun is but one. And the universe is filled with hundreds of billions of galaxies. A lot of them look a lot like our own, but we don't really know how they got there, right? We know the universe started with this big bang somehow, right? Everything expanded away from everything. And then somehow, galaxies form, stars form, planets form, people come about. And that's what we're trying to figure out is, where did the galaxies come from? And so the kind of stuff I do is I look at really, really distant galaxies, the furthest ones that we can see away from us.
So why distant? Why does distance matter?
It's a good question. So, it's not just bragging rights, like we saw the most distant galaxy, so
okay.
Ha ha ha. It's that the speed of light is finite, right?
Okay.
You know this at some level, the Earth, the speed of light, if you travel at the speed of light, you go around the Earth 7 times in 1 second. It's fast, but it is finite. And so if you look at things that are, say, 10 light years away, you see them as they were 10 years in the past. And the thing about distant galaxies is if you look at them billions of light years away, which is what we do, you see what galaxies looked like billions of years ago. And if you're trying to figure out how did they form, how did they evolve, how did all of this come about, looking at distant ones is like looking at baby pictures of our own galaxies, and we can actually start to learn something about where they came from.
So in a strange way, you're kind of almost, you're looking back almost at the formation of what, like us, like there would be a similar story maybe out there that might have like the qualifying conditions even for life.
Absolutely. I mean, that's a big step from the initial seeds of galaxy formation, but ultimately, yes. I mean, we try to look at things, for example, that we think might eventually become galaxies like our own Milky Way, right? The Milky Way, we think, is something like 10 or 11 billion years old. The universe, we think, is about 14 billion years old, so the Milky Way forms a few billion years after the Big Bang. But we have no idea what it looked like when it was forming. We have all these guesses, right? We think it was probably this like chaotic mess of like gas coming in and, dark matter and stars forming like crazy and a black hole and all this nutty stuff happening. But we've never seen it, right? And, seeing is believing at some level. And so what we're trying to do is, take pictures of all this very, very early stages of galaxy formation, all this chaos, and somehow, figure out how all this chaos turns into this order that we see now. We have this nice, disk galaxy that's going around, all filled with stars, filled with wonderful planets like our own, right? So that's kind of the game that we're working on. And there's all sorts of exciting stuff coming up in the next few years that are really going to completely change the game for doing that for us.
So does it, I mean, you're so deep into it, but for an everyday kind of lay person like me who looks at this stuff, I mean, the magnitudes of time are like literally on billions of years. I get impatient if something takes me, like 3 minutes or something's too late. And then you're describing stuff on the order of like billions of years. I mean, that's a long time to kind of wait around to see something. And but you're talking about interesting developments happening in like the next little while. Is that we're about to see some things that are about to happen, or we've seen certain astronomical or kind of cosmological events that are occurring as of late? I mean, can you kind of dig into that?
Yeah, absolutely. So the thing we're all really, really excited about is this new telescope that's coming. It's supposed to launch in March of 2021. It's called the James Webb Space Telescope. It's NASA's successor to Hubble. So, probably people have heard of the Hubble Space Telescope. It's pretty famous, and it's been around now for almost 30 years. And it's completely changed astronomy, right, in so many aspects. And it's brought astronomy to people with all these beautiful pictures. And for those of us who are really interested in, the earliest times, just about everything we know about the earliest times for galaxies comes from the Hubble telescope. But, it's kind of run out of gas in some ways. It's only so big, and even worse is it can only go so far into the infrared.
So why does that matter?
Yeah, good question. So you and I were talking about this a little bit before we started taping. Everything in the universe is moving away from everything else because the universe is expanding.
Okay.
And so when things move away from you, their light actually gets shifted into the red. It's the same kind of thing it's the same kind of thing as the Doppler shift here on Earth, what is the Doppler shift? But you know how you're being chased by the police, which is
very often.
Yeah, it's a common thing.
In my case, so.
Yeah. Well, I know how fast you drive.
This is true.
But when the police car's coming at you, the wail of the siren is quite high pitched, and then it goes past you, and then the wail of the siren actually becomes quite low pitched. And this is this Doppler shift, that sound waves become compressed as they move towards you, and then they get stretched out as they move away from you. Light behaves exactly the same way as sound, and so when things are moving away from you, light waves get stretched, and they go to longer and longer wavelengths, which means, the kind of light that you and I look into, the visible, gets stretched into the infrared.
So we can't see that stuff, but
Absolutely.
Those are the types of things that you're studying really that are really far out, so they're, in a sense, redshifted.
Exactly.
Okay.
Yeah, exactly. And so Hubble has the ability to look a little bit into the infrared. And so everything we've learned about very distant galaxies, we've learned from the very reddest thing that Hubble can do. But the James Webb Space Telescope is so much more powerful than Hubble. So the mirror is almost 3 times larger.
Oh my God. Okay.
Yeah. And it goes, much further into the infrared. And so if you think about it, we're trying to look at the most distant galaxies. They're going to be further away, so they're going to be fainter. So we need a bigger mirror, we need a more powerful telescope, and then we also need to look into the infrared because everything is incredibly redshifted. And so this new telescope that they're building, the James Webb Space Telescope, does both of these things. Now, the thing that will scare you is that, it comes at an incredible price. So we've had a few mission delays, and right now this is the most expensive single satellite that NASA has built at a cost of $10 billion with a B.
Okay, so I can't put this clearly on my credit card. It's slightly more expensive than that. $10 billion, that's a lot of money for a telescope.
That is a lot of money for a telescope.
So tell me, people keep, they're going to rag on this. They're going to go, we're spending a lot of money on science. Why are we spending money on this telescope? Why does astronomy matter? I know my personal reasons for it because, it fascinates me. There's a lot of stuff that kind of frightens me, black holes, this cosmological horizon, which I will pick your brain on in a second. But why, what do you say to people when they say, we're spending all this money on science, especially astronomy? Why does it matter?
There's so many reasons it matters. I can tell you a few of them. Some of the obvious stuff, if you're thinking from a business standpoint, is technology development. CCD cameras, all of this kind of space stuff is stuff that ultimately gets used in the private sector. NASA does so much technology development. So a lot of this money, you think, oh my God, $10 billion, right? Where does this go?
Yeah.
But a lot of it comes all the way back around in a circle. It's a long circle, right? Because it is this technology development, and then it has to get privatized, and then monetized, and et cetera. But NASA has seeded so much technology that's come back. I think the other thing that if you're interested in where it goes is it goes in training people. We were talking before. You have a science background, right? Absolutely. And there's so many people that ultimately go into science that learn, how to be scientists and work on these kind of projects. Many of my graduate students work on these projects. And then they go on and take that knowledge and move it into the private sector. Many of my, former graduate students are working in data science, working for, what are they working for? Banks, working for Facebook, working for booking.com, all these kind of places where they've taken, learning how to analyze real data and then use those skills in the private sector. So we're developing technology for the private sector, we're developing knowledge for the private sector, and then, but that's also not how we think about it. The other reason for this is I think just, the beauty of dreaming, of being a human and wondering, where did everything come from? Why am I here? Why is the Milky Way here? Why is there life on Earth, right? These are questions that I think any of us who have, I don't know, sat out in the backyard and looked up at the stars with a beer have been thinking, like, how did all this happen? And we're trying to answer those questions. And I think people want the answers to those questions on top of all of it. So it is expensive, but, we provide technology, we provide training, and we answer, I think, exciting questions. And so I think it's worth the money. It's a lot, but I think it's worth it.
When you frame it that way, when you say that, and you and I had this discussion earlier on, right, where we talked about how the entire space program, the kind of 50s, 60s, really inspired the entire kind of microprocessor and transistor race, and all like microelectronics. So much of that came from their lasers. All these other lasers came from there. And even, so much of the computer industry, we owe kind of a debt of gratitude to that entire that endeavor, and that I wouldn't, frankly, be in my industry if it wasn't for, from this to say from the entire space race, I wouldn't be here if it wasn't for that. So I think, to your point, we do kind of owe a debt of gratitude to that for dreaming. But, for as long as I can remember, I was also a fan of Star Trek, right? Like the entire point of, these phones and these iPads and, big screen TVs and all this stuff is, and just Skype, the entire point of like visual communication was inspired by these people who had no idea. They just kind of had to make it up. They dreamt.
Yeah, absolutely.
And the entire concept of, warp drive, faster than light, and they didn't have the science, so they kind of thought it up and they just abstracted into this black box, and that here we are today. We kind of take for granted. So I fully agree, and into some sense I think people do need to see that these types of sciences, these empirical sciences, are like very much inspirational, and they constitute the base for so much of the stuff we do.
Well, let me give you another example, right? Everyone is really excited by SpaceX, right? Elon Musk is awesome.
Yes.
All this kind of work that SpaceX is doing, and they are, and Virgin Galactic, right?
Yeah.
Who are struggling a bit, but are I think
Bezos
getting things
at it too.
So yeah, exactly. And so, space is being commercialized. Ask yourself if that would be possible without the steps that NASA has taken since the 1950s, right? They have, what is SpaceX doing to get off the ground? They are supplying the International Space Station with supplies, right? They're not building a space station. No one can start up a company
Right.
to build a space station. It's a tens of hundreds of billions of dollar endeavor to build a space station. But you can start to supply the space station. And now they're working with putting manned spacecraft on the end of SpaceX's rockets, right? So it's a procedure where government and NASA blazes a pathway in something that's just not financially viable today, but in the future will be, right? And all space business that gets done, I think, when you and I are very old men, you will have to say thank you to NASA and the government for blazing that trail, right?
Are you seeing, even from your position right now, a little bit of the erosion of that, or are you seeing more popularity, like stuff is getting in the news and you're seeing more people come into it, and kids these days are fascinated by science? They're going, you know what, I really want to find out, or I want to build the next rocket that's going to land back down, as opposed to just having these parts fall off into the ocean, right?
Right.
That we can just it's possible to recycle it. Are you seeing more interest in STEM and particularly for astronomy, astrophysics?
I'm still a young professor, but I think the interest is there. That's always been there. There's tons of people who want to do that kind of stuff. People are really excited by that kind of stuff. I think it's scary getting into it because it's such a huge industry. But I think there will always be people who want to do that.
Like, it's not gonna, in my hope, it's not gonna die anytime soon, because everyone just wants to go and become a data scientist or make the next social network or something.
No, young people are incredibly inspired, right? That's another great thing about doing this kind of blue sky science, is that it's the kind of stuff that really inspires young people. I'm sure there are lots of inspired tax accountants. You know what I mean?
Yes.
But I would place them against my young astrophysicists, every day in a competition of who's feeling more inspired on a given day, and I think we would fare extremely well, right? People are really, really keen to make advances for mankind.
So I'm gonna switch track to something and be a little bit self-indulgent.
Yeah,
and,
sure.
And pick on two areas that frankly inspire me and frighten the crap out of me.
Sure.
Okay. One is black holes. I know we're not near one. Well, in any like reasonable
They're scary.
sense.
They're really scary.
But the concept of this thing just frightens the crap out of me. The second thing is this entire concept of like the cosmological horizon, and what's beyond that? I know there's stuff beyond it, but it starts raising all these philosophical questions about the nature of, if you can't see it, does it still exist? Well, you can postulate. So, dealer's choice. What do you want to tackle first and frighten me with?
You want so. I won't frighten you with either. You want to start small, quotation marks, with black holes, and then go up, and then go big to the cosmological horizon.
I'm your student.
Well, so black holes are awesome. You probably saw this. I mean, hopefully a lot of your listeners as well saw this press release of this image that was taken of a black hole, which, all of us. I mean, I remember I was watching the press release and I almost fell out of my chair. It's absolutely stunning that we can do this, and this is not the place to do this. But remember, these people built a telescope the size of the planet in order to do this, which is kind of, I don't know, it's amazing on how many levels, not from just a technical standpoint, but to get people from like 20 odd countries to all, work together and, use their telescopes from, Antarctica to Australia to, Europe to South America to North America. It's an amazing endeavor in human cooperation as well. So it's a really beautiful thing. But I wouldn't worry about black holes too much if I were you. So there is a black hole in the center of our galaxy, but it's really, really far away. It is about 25 to 30,000 light years away from us.
So if I traveled at the speed of light, it would take me 25 to 30,000 years.
That's right.
To get there.
And if you think about how long it's taken for like Homo sapiens to evolve, it's something like 100,000 years. So, if you had left around the time that man was starting to develop agriculture and just pull himself out of hunter-gatherer societies, you'd only be getting there now. If you were traveling at the speed of light, it's really far away. So it's not gonna harm you. And I think the other thing people need to know is that black holes don't suck anything in. They don't suck. So
explain that. Why do they not? Because everyone's got this in sci-fi. They've got this notion of you're gonna get sucked into this thing and then you get destroyed, and then I've heard this spaghettification and all this stuff. Like they toss these words around, but lay it down. Like, what's the actual truth about these things in terms of do they suck stuff in? Is it just if you get too close, then it's the point of no return? What's that all about?
I think you said it. You're a wise man. If you got way too close, you would get sucked in. But for example, a great example is if I took our sun, right, and I made it into a black hole. I just gave it was the same mass, but I made it into a black hole. What would happen to the Earth's orbit? Any guess?
You're saying, so the same mass, and I'm going to guess here. So if it's the same mass.
Yep, same mass. I take our nice big fluffy sun and I crush it down into a black hole that's just the size of a pinprick. So
nothing would happen to our orbit.
Nothing would happen to the Earth. That's right. We just keep going around in a circle, right? Nothing at all would change. Because that's how orbital mechanics work. So the only time you ever have to worry is if you got really, really close to a black hole. And I'm talking even closer than the Earth is to the sun, right? And the Earth to the sun is about 8 light minutes. So 8 minutes at the speed of light, you would hit the sun. Remember, I'm saying that the Milky Way black hole is 25 to 30,000 light years. So even if you're only 8 light minutes away, you still wouldn't fall in. So you don't have to worry about it.
So what happens? I mean, you get close, and this entire concept of this event horizon.
Oh yes.
We can't see anything beyond it, and why is that? Why can't we see anything beyond it? And what does that tell us about the nature of existence? Stuff falls in, it doesn't come out, and we learn about thermodynamics, and isn't that stuff falling out of our universe then? Isn't that kind of this principle being violated over here? Am I kind of asking the wrong question?
No, you're asking the right questions. There's 5 of them in there, and they're hard ones. I mean, we don't know a lot about what's going on inside a black hole. The idea is, so we think black holes have an edge, and this is this thing you mentioned called the event horizon, which is this edge is where even if you were inside the black hole and you set off at the speed of light, you could not get out, right? Light cannot escape from a black hole.
So I'm inside. I fall inside the event horizon.
Yes, you can't get out. Even if you traveled at the speed of light, you could not get out. And
so how fast would I have to go to be able to get out if I fall in?
Well, faster than light, which we don't think is possible. So you're never getting out in principle. But that's a whole other thing to get back to. But so the event horizon is kind of the size of the black hole at which if you were just outside the event horizon, if you traveled at the speed of light, you could eventually get away from the black hole, but it would take you millions of years. Once you cross over the event horizon, you're never getting out again. So it's kind of a place where and we won't go into relativity, but because you're going to be traveling close to the speed of light, time stands still. And so that's why it's called the event horizon. Events no longer occur at the surface of a black hole because time is sort of effectively standing still, which is a weird concept.
So does this entire concept of, like redshifting also apply to a black hole then?
Absolutely, yeah. Well, did you study astrophysics?
No, I mean, I'm taking from what you've kind of told me, right? Because it's like stuff gets stretched.
Absolutely.
I'm only just presuming.
So in fact, that's what it looks like actually, is when something falls into a black hole, if you were to watch it fall into a black hole, it would kind of get smaller and smaller. And then just before it hits the event horizon, what you said would happen is it would get massively redshifted because the light is trying to get out of the black hole. And it is, but in the process, it's being massively stretched out by the gravitational field. And so things actually turn super red and then disappear as they fall into the event horizon.
So would I ever see, like if, some guy on a rocket is going near a black hole, would I actually see him or her falling in?
What would it look like if they went in?
Yeah.
What would you see? So you would see them getting smaller and smaller as they got closer and closer, and they eventually would start to turn redder and redder and redder and redder, and then one day you wouldn't see them.
Because I just can't perceive that, like it's
well, even if you could, eventually once they cross the event horizon, they kind of vanish.
And so what, in your understanding and view, like what is the inside of these things? People talk about, is there a different universe, different reality? I know Neil deGrasse Tyson, like he's, I love the way he articulates things, but, I want to find out more. Like, is there a theory? Does it become philosophical at that point, or is it more scientific?
Well, so we have no theory. So what we need in order to understand a black hole is what they call quantum gravity, which we don't have. And the idea is, and your listeners who may be somewhat fans of science, the law of gravity, as we know it now, is sort of Einstein's theory of general relativity, and that explains how gravity works on very large scales. On very small scales, we know that the way things work is with the laws of quantum mechanics. However, if you think about it, the very central part of a black hole is very powerful gravity on a very small scale. So you need something that, obeys the laws of general relativity, but also obeys the laws of quantum mechanics. You need a quantum theory of gravity, and we absolutely do not have it. And we've known we've needed this for a very long time, and it's just, we haven't had a way of really understanding how to make that kind of stuff work together. And so we can't really explain what's going on inside a black hole. People work on these things, but it's just incredibly difficult. Now, some of these observations we're taking, like you saw this image of a black hole, they help a little bit. They confirm that even on the size scale of a black hole, they look like what general relativity predicts. And we didn't know that, right? So general relativity holds right up to the event horizon of a black hole. We learned that this year, which is really, really exciting. But we still, if you want to know what's going on inside the black hole, I have nothing. People have theories, of course, but I have no way of really knowing of any of it.
I guess that's where my question kind of came in at that point. Does it really become more of a philosophical or creative matter where people are going to come up with a guess as to something and then say, let's go out and try and find the data. But from what you're saying, like nothing really comes out of there. So you can't really prove your hypothesis. I guess you have to have a way of observing what kind of happened, right? Or like inside
absolutely.
it. But how do you get that?
But also, like, I don't know how to, you've taken a degree in math, so you understand that there are just ways of writing down math that don't speak to each other, if you know what I'm saying. And general relativity and quantum mechanics are like that. They just don't know how to speak to each other. They're like in two completely different languages. And so you would think, this happens in physics when we realize that in fact, general relativity was taking Newton's laws, all these things like, how balls fall off roofs and stuff that Newton was working on, and putting it in a much larger context and realizing that all the things Newton wrote down were just a small part of Einstein's theory of general relativity, that they're just a special case of this greater understanding. And what it must be is that quantum mechanics and general relativity on their own, while incredibly all-encompassing theories, must be special cases of some much larger theory of everything, right? Which you may have heard of. There was a movie, this is the kind of thing that Stephen Hawking
the theory of everything,
yeah,
right?
Stephen Hawking was very excited about this. They made a movie. The movie of his life was called Theory of Everything. And so this is what people want, to try to make these other theories, special cases of this larger theory of everything. But we really don't know how to do that at the moment. And it's, It could be a very, very long way off. Although I don't want to discourage people from trying to solve it, because it would make my life a lot better if someone could come up with a theory of everything. But it's hard. We're waiting for the next Einstein.
Do you think we're going to see this type of theory like within our lifetimes, or do you think it's we need to evolve as a species to some other, not only just in terms of our own mechanization, or maybe rely on AI to be able to come up with these types of theories, or figuring out how to peer into the nature of higher dimensions that we ourselves can't even perceive at this point?
These are fantastic questions. I love these questions, and I don't know. I mean, it's so hard to say, when does scientific discovery happen? Particularly, when does absolutely groundbreaking scientific discovery happen? No one knew that Darwin, sailing on this boat to the Galapagos Islands was going to revolutionize biology, right? He was just some guy going on a boat trip and then went, I got an idea. And so I have no idea. It could be a long way off. On the other hand, you said something that's really exciting to me, which is AI, right? I mean, I think we are, those of us in science see the AI, everybody sees the AI revolution coming. Those of us in science see the AI revolution coming, but we have no idea how to use this thing.
Well, tell me, because I live in a world where there's so much hype about AI, and I'm giving a talk in a couple of months about this, but what is your view on AI? I mean, as far as not only your field is concerned, but how you see it kind of in society. I'm very fascinated because you've got a very different lens than what I kind of bring into it, right? So what does AI mean to you as a professional, as a citizen,
right? So, before I get on a soapbox, it's a natural progression. I think it's super scary to everybody, but this is happening, right? This is happening, and so does it make your life better? I don't know, but it's going to happen, and so I think now is the time to embrace it. You can imagine a future where it does all sorts of useful things in society, and so then to take the lens to my own field, I mean, you're talking, we were just talking about probably the hardest problem in physics, right? The theory of everything. There is no more difficult problem in physics, and we have made limited progress on that for a long time, and it might be that AI is capable of that. Wouldn't that be really exciting? And then you would say, wow, there's something that AI achieved that humans, well, who knows, after 1,000 years we may have achieved it. But AI might have sped up the process by a factor of 20, that it got done in 50 years instead of 1,000. And so that would be really exciting, right? I think the thing is that people are bringing AI into scientific research. I'm talking from the astronomy perspective, in very limited ways, kind of step by step bringing this in. In my own field, people use it to classify galaxies. Galaxies are like people, they all have different faces and heights and hair colors, and they're all kind of the same thing. They're all galaxies, just like people are all people, but in detail they're quite different. And so AI is very powerful at spotting trends, and so people are bringing it in to kind of do these smaller tasks. But you can imagine a future where, as you said, it actually not does it just do a little bit of cataloging for you, it solves problems, right? And that would be really exciting.
I've worked on, we work here with AI every day, and there's in the dotcom field, there's companies that are coming up with really expedient AI, right? We've figured out classification generally, 40s, 50s, and a lot of the theory was already done, but now we just have faster computers. So you just see, okay, when you can just use Google or Amazon, they've got these APIs, you can just upload it, can tell you the difference between a penguin and and a cat. However, there's still the kind of the hype surrounding it, going, well, if you twist the penguin's picture 30 degrees to the side, it'll think that it's a shoe. So, and then you have to go back, I need to train it on that stuff. So it's only good as the training data, and ultimately the human being is going to help classify it. So when people say, AI is going to kind of take over the world or be capable of truly original or novel thinking, my contention there is that, mathematically, it's just a really efficient form of just, Lego, right? You're still got the original pieces, but who's going to come up with a different piece of Lego? And I think that's where the novel thinking is going to come in. Mathematically, we're not there just yet. So, a lot of journalists, and I know I'm going to get a lot of, the comments and the flack on this, from the comments on this thing, that we're not quite there yet. It makes for a great kind of commercialization, but to the, your point, if we can help catalog these things a lot faster, I mean, absolutely, there should be this congress and this conversation between the people who are making the tools and people who need to use the tools for classification. But for an AI to come along and say, well, I'm going to now, instead of outsourcing data cataloging, I'm going to outsource thinking itself. So if I kind of work my way up my mental pyramid of sorts, where it's no longer just hands, it's actually the cognitive processes where I'm able to perceive of not only just senses that have somehow differently been abled by AI. That's when stuff starts to become both exciting and frightening at the same time. Because imagine, I mean, we perceive of a certain way of doing things. We have a certain ethical and kind of a moral compass and societal mores within which we kind of operate. And we've tried for the most part to endow AI with these types of things. But if we just say, look, here's what you need to optimize, it's just profit. And then it can run away. And as we've seen, to sometimes disastrous effect, where for the price of just going out and making profit, it'll just let anyone bid on anything, whether it's advertising and if you start deploying it in other areas where we start to literally give it arms that it says, okay, well, this is okay for me to kind of cut my losses on, or this person isn't as important, or let's not worry about that election as much because we needed to earn the profit without taking any company names. Right, this is where for me, like, we need to start making those trade-offs. But in the meantime, it sounds like there's so much application just for fields in, they can catalog galaxies, for instance, right? Like, because that might help us discover, to your point, how stuff works.
Well, but I agree with everything you said there. I think, so there's a saying, with great power comes great responsibility. And I think what you're talking about is that we're starting to recognize that AI has power. Right. It has when you're talking about, bidding on things, changing the world economy because half the trading going on is done by computers and, can crash the entire monetary system if an AI system, is not whatever. That's real power. That's power, to run commerce. And the more power we put in the hands of AI, the greater responsibility we have to make sure, as you said, it's being done ethically, right? And there is a movement, to try to make people aware of this, and things are changing. I thought it was really interesting there. Google finally said they're not doing any more military contracts, and of course they didn't say why or exactly what they were working on. But if you had an imagination, you might think, these guys were building AI for killer robots and recognizing that, like, if we build this so efficiently and we put it in the hands of, say, people we don't have the same moral values of, what's happening with society? And so even if there's profit to be made here, which I'm sure there is plenty, we're going to take ourselves out of this. And so, it's scary, but it's good to know that at least, some people are trying to think ethically and recognize the real power in this kind of stuff. So that's something we have to realize moving forward. It's powerful, and we have to be responsible.
But in a strange and perverse way, to circle this back, this was all caused by NASA and and been inspired because you create this entire arms race of technology that the astrophysicists and the people who wanted to go to the moon created computers, and now we just use that to kind of enable commerce. Yeah, granted, commerce has been around forever and a day, but there's certain noble, more noble endeavors that we can certainly be putting this toward that aren't necessarily going to be kind of harming society.
Yeah,
where people
absolutely.
want to develop these STEM skills and kind of go into it. Right?
Absolutely. So there's a huge future in AI. Excuse me. There's a huge future for AI and science as well, and we're just trying to figure out what that is.
Is that something that you are interested in right now from the data that you are gathering? And was AI used to look at this, the picture of this black hole, or is it going to be used in James Webb and to be able to,
So presumably, I'm not doing. So I've kind of, on purpose stayed a little back from the AI revolution at the moment. I think just because there's a lot of things I'm interested in that don't need it, and right now, it's a risk, right? I mean, here you guys are probably always making these R&D choices about, what is the long-term investment of my R&D? This could become something huge, but it might take 10 years, and this might be something smaller, but I recognize that, you're always making these trade-offs. And so in my own research, I sort of see a lot of exciting stuff on the horizon. And my friends who are using AI, I think, 20 years from now, I'll be jealous, and I'll probably have to catch up. But right now, I'm not doing so much of it myself. It's really useful at the moment, as you say, on these cataloging things, these big tasks. that you would get, back in the day, we just hire 10 graduate students and feed them bread and water and whip them and make them spend 2 years of their life doing this. And, instead now we hire one graduate student and we, give them some AI, machinery, and a year or two later they come back.
Well, I keep hearing, because the stories about this black hole story that came out too, they said, they used a lot of AI-based kind of number crunching for that, and then there was LIGO, and then as well as with the LHC, that they had used a whole bunch of AI technology just to crunch at the massive amount of data that clearly came out. I mean, that's a lot of grad students, right? I mean, and that's a lot of PhDs. But I mean, we would have been here till the year 3000 if they were just crunching at it.
Absolutely.
So there clearly seem to be kind of benefits in
absolutely.
that regard.
Oh, absolutely, absolutely. There's a ton. There's absolutely a ton.
But from your scope right now, I mean, because you're looking at stuff, and I wanted to bring it back to to you and what you're doing a little bit, because again, these are areas that are both fascinating and frightening. You're looking at stuff that's really far out. Do you use a lot of kind of data analysis techniques to be able to look at all these things that are super, super far away and figure out the nature of them and what's going on?
Yeah, I mean, so we're always trying to do fancy image processing. I mean, one of the things that's horrible about my field is so many people keep up with astronomy and they see these beautiful pictures, these press releases from Hubble, all this stuff. And, my parents, they're like, why don't you take pictures like that? But, when you're looking at...
Why can't you be like him?
Exactly. But, when you're looking at the most distant galaxies, they don't look like anything. We see these little faintest flecks of fluff in the longest exposure that Hubble takes. And we're like, I think that's something, and we have to get there, and we spend a lot of time figuring out what noise is, because we have to decide if the thing we've seen is just
that little speck.
Yeah, is that static? Is that noise? Or is that actually something? Because we are looking for absolutely the faintest, most distant things, right? So we're doing all sorts of sort of fancy image processing to figure out, this is signal, this is noise, this is statistically something, this is statistically not something. So unfortunately, though, it doesn't make for beautiful press release photos, right? Well, I can show you these distant galaxies, and it really just looks like if you squint, and you have to squint the right way, and you have to turn the image a little to the left, that there's a fluff ball there, right? That's kind of what we've discovered. And so, it's a lot of work on image processing, really pulling out incredibly faint signals.
So you've got these signals that are from really far away, these flecks.
Yeah.
You told me that the universe was expanding.
Indeed.
Does that fleck go away eventually?
Does the fleck go away?
Does it go beyond, eventually? And I don't know if I'm asking it the right way. And sorry, correct me. I'm asking from a layperson's point of view. You're telling me the universe is expanding, but does that fleck eventually become more and more red to the point that it goes away somewhere, and beyond which you can't see?
Yes.
There's some boundary, and then what happens? If you extrapolate this long term, what happens? Is there something beyond the beyond, and is that more philosophical or scientific? And this is the second part of my frightening question.
Do you want the long answer or the short answer?
I want you to educate me.
Okay, so the short answer is maybe.
Okay.
The long answer is we don't really know. So things are moving away from us. However, they're not moving away from us at the speed of light. So if that's true, then we'll always be able to see these things, if you think about it, right? It's only if they started moving away from us faster than light that they would eventually disappear. Does that make sense? Well, so if I run away from you,
right,
on the street, which probably I've done at some point in our lives, running to class, I don't disappear. I am moving away from you, but I don't disappear because I'm not running faster than the speed of light. However, if I was really late for class and I got up to the speed of light, then I would eventually disappear. So the question is, will anything ever be expanding away from us faster than the speed of light? And the answer is maybe. We don't know. So about 20 years ago, there was this discovery of this thing called dark energy, or that the expansion of the universe is accelerating. This was, for your younger listeners, this might be new, but for people our age, this was kind of right when we were in our 20s. They won the Nobel Prize for this, right? Discovering this dark energy accelerated expansion of the universe. And so we don't know what this thing is that is causing the universe to inflate faster and faster and faster. Now,
is this thing that they were related? Because I remember it came out in 98, the big rip they were postulating about, and that things aren't moving, but space itself is somehow expanding. Now, is dark energy part of this expansion of space for a reason that we don't know of? Is that all related to it? Because I only just read like a Time magazine article in
no,
like 98.
you're absolutely you are absolutely right. So in a normal universe, you'd think, okay, well, it would start expanding. It's got gravity in it. Gravity's attractive. It would start to slow down. And our universe is the opposite. Not only is it not slowing down, it's actually speeding up how quickly everything is moving away. And so we've given this thing causing this speed up dark energy. We've given it this name, dark energy. What it is, we have precisely zero idea. We have absolutely no clue. There is no particle theory. There is no understanding of it at all, what dark energy is. We know it's there. We can see its effect. We can see the universe accelerating, but we don't know. And so, trying to circle back to your original question, which is, will these galaxies eventually disappear? The answer is actually, if dark energy keeps behaving the way it does now, yes, they will eventually, because the universe is accelerating its expansion. And at some point, things far away from you will actually start moving away from you faster than the speed of light, and you'll lose sight of them.
So where do they go? Do they just go beyond this causal boundary of sorts? Like, we can't see?
That's kind of the way to think about it, is that if something is moving away from you faster than light, then you can't see it anymore. The light can't get
is there stuff already there right now? Like, in that sense, is the universe infinite, or is that even a right characterization of things?
So no, well, we don't think so. But again, I mean, you're cutting right at the cusp of all the things we don't know. So we don't think so. Our horizon is quite big. We can't quite see back to the Big Bang, but it doesn't matter because there's stuff in the way anyways. So we can see very, very close to the Big Bang. We see this thing called the cosmic microwave background, which is like a whole other hour-long podcast. So there's nothing there, we think, yet. But as I said, if dark energy keeps on doing what it's doing, then eventually that will happen. Now, the thing is since we don't know what it is, it could change its mind tomorrow, right? It could be like, I'm going to accelerate the expansion of the universe, and it got to a certain size, and you know what? I've changed my mind. I'm going to start contracting the universe, right?
Because so we literally know zero about it right now,
literally
except
zero.
For the effect that it's having.
Exactly, and
currently.
So we can't predict the future of the universe. We can assume, look, it's going to do the same thing tomorrow as it does today, and it's going to do the same thing the day after, and blah. And if we do, then what's going to happen is what you said, is we're going to lose view of all sorts of parts of the universe and what's called a big rip. But if it changes its mind, which it's apt to do if it wants to, if we understood what it was, then that might not happen. And
I can't.
And so that goes back to the short answer was, maybe.
So I can't accept this because it continues to bother me. And it's, this just makes me, and as silly as it sounds, these types of things genuinely do bother me.
They should.
I don't know what exists beyond, right? And while you talked about the link between math and astronomy, and math, I'd say, in my experience, has been it's concrete, and so based on your premises, if you follow certain rules of deduction, they make sense. And then based on the axioms that you tend to use from mathematics, or from set theory that you have, it kind of emerges from there that the maths kind of make sense. Yes, there are kind of different branches of mathematics. They might talk to each other. Generally we try and use mathematics to be able to support kind of the empirical sciences. But here, the really kind of, discomforting thing in a certain sense is that there's so much that we just don't know. We probably know more about math than we know about, frankly, like how, from what you're saying, how stuff even works. There's everything from, string theory to, like loops and all these, the multiverse, and, it turns out DC Comics and, these guys may have been right? So,
Absolutely.
About the multiverse, is this stuff that you also kind of, have to confront and talk about on a regular basis?
Yeah, absolutely.
So what is the multiverse?
Oh, good question. Well, so let me take a step back before I answer that and talk to what you said, which is it is scary how much we don't know, but go try to find a textbook from 100 years ago and realize how much we know now compared to what we knew 100 years ago. And it is absolutely staggering, right? It is staggering what we can talk about now in the realms of particle physics, the idea that people are taking pictures of black holes, that we kind of understand the origin and evolution of the universe, which none of this they understood 100 years ago. They thought the Milky Way was the entire universe, right? Captain's 1922 universe was the Milky Way, which is nothing, and so, and when you say, well, 100 years is a long time, but you think, yeah, but actually it's really just one human lifetime. Well, I mean, a very long human lifetime, but it's literally one lifetime. We've gone from understanding so little to so much. So it is scary how little we know and all that kind of stuff, but it's amazing how fast we're actually moving. And it could well, you've got a young boy who's 4 years old, right? And he may live to 104. And what would be so cool is if this podcast was kept, and 100 years ago 100 years from now he listens to this and goes, oh God, they were worried about all that stuff. We solved
how
that.
quaint. Right?
Yeah.
They thought the elements were like earth, air, fire, and water.
That's right.
Like,
we solved all of that in 2085. So things like multiverses are things that so you asked about multiverses are things that people are talking about. 30 or 40 years ago, if you said that to a theoretical astrophysicist, they would probably laugh at you, right?
But it seems to be in the here and now, where
yeah,
people
absolutely.
are like taking
absolutely.
it seriously. But it was that ridiculous back then.
It was. I mean, it was pretty ridiculous because there was no need for it. And now, we know so much about our universe on a cosmological way that we start asking deeper questions, which is like, okay, now that we know all the bits and pieces to pretty high accuracy, where did it come from? Why does it look this way? Why is the force of gravity this strong? Why isn't it stronger or weaker? Why is the ratio of mass between a proton and electron what it is? Why is the electric charge the value? These kind of things that could have been anything, but are what they are. And so this is the kind of thing that has then led people to talk about potentially multiple universes, that, in other universes, they are different values. You just so happen to live in one of, millions, if not infinite, universes, and this one has all these kind of properties, but they could have been something else. And it's a little bit comforting because in science, it's very uncomfortable for us to have these kind of built-in numbers like the strength of gravity, or
like these magic numbers that are just these constants.
Yeah, they're magic, right? And we have no idea where any of those come from. And multiverses are a way of trying to deal with that in some way. The only problem with it is that it's very difficult to test. People can write down theories of multiverses, but if we can't see them or talk to them, then it's hard to distinguish if it's right or wrong. But, who knows? It could be that in 100 years we find ways of actually, potentially seeing information transferred between different universes, right? Who knows? Maybe there is a way through black holes or something like that. We really just don't know. I mean, these are things that are on and I love these questions because these are frontiers that are even beyond our current frontiers. I mean, these are really the kind of things we dream about in the future. But it's easy to imagine that in 100 years these will be absolutely the forefront of science.
So I will make an observation. I mean, as I'm listening to you, you say a lot of things that are, say maybe, and there's an element of almost innate creativity to what you're saying. And these are things that I'm not sure whether necessarily an AI is going to be able to just, kind of postulate this abductive type of, creative reasoning. It may be able to crunch, but it may not be able to dream, as it were. And it sounds like there's certainly, and from my observation, there's an element of creativity. There's an element of imagination, of, postulation, of pontification, of some type of dreaming, and then trying to go out and find those things in there. And I can't help but think this is also because you are not purely cut from like a scientific cloth. I've known you long enough to know that you're a wicked bass player and that you've had a prior life and as a musician. And I can't help but think also that part of your creativity also comes from that. So tell me a little bit more about do you believe that the arts and this type of exploration is, from things that are non-quantified, what is their role in the scientific? Do you think they have their place in there? Because people are talking about, the liberal arts, well, maybe not. Let's push everyone to go and get a Udacity degree in, data science, right?
It's incredibly
should someone pick up a bass and learn, right? And what the arts are about, or go and take a dance class? I mean, what you are you're a teacher, you're a scientist, and you're in the quantitative empirical sciences. Where does the arts fit in for you?
Oh, yeah. I mean, I'm glad you asked. I mean, it is a tragedy that we are removing the arts from so much education. It's so hard. I mean, and the reason why, I think, is that So I think they're absolutely essential for doing things like science. I agree with you that creativity is not something that is categorized into arts or science, right? Creativity is creativity. The problem is that it's hard to quantify, right? And everybody loves metrics, right? The world is metric driven. So, no one sits around and says, well, if we take our kids, if they take so much art and so much music, and so much drama acting in high school, then they become better. No one does that metric, right? And it's hard to quantify. However, I think anyone that you see that's doing cutting edge stuff in the arts or in the science has this, I agree with you, this element of creativity. And so you want to have people explore that from a young age. I mean, one of the things we've known about education and child development is the younger you introduce things to people, the more it becomes part of who they are and increases the rate at which they learn. And so it's not a surprise that, in fact, yes, many scientists have artistic backgrounds, and in fact, many scientists have, many artists have backgrounds in things like math, etc. I can show you a lot of artists who have studied the scientists. So it's an incredible tragedy. But ultimately, going back into the my own realm here of science, I mean, that's what it's all about, right? I mean, everybody loves the story of Einstein, right? I mean, it's this, everybody loves the story of Einstein because here's a guy who came and he was a patent clerk and he just sat at his desk and he just had these wild ideas, just wildly creative ideas that, are so out there and yet have proved to be so right, and he didn't need a lab. He didn't have really formal training, right? He just kind of used his mind. And it shows you that if you develop those kinds of things within people, however you do it, in science or in the arts, that, the human mind is a powerful, beautiful thing to do this kind of stuff with.
What role has art, played in your life? I mean, you may not be, again, to your point, you may not be able to quantify it to say, well, because I was a musician that I was able to, understand these things. But in your own words, I mean, what did being a musician do, or like how did it help you in your career?
I mean, again, it's hard to quantify, but maybe I'll twist it a little.
Was it a feel for something? Did you find a groove with?
It changes the way you think about things. So one thing let me come at it from a different angle and then go back to music. But for example, one thing they show is that people who speak more than one language tend to be much more creative and tend to have much better problem-solving skills. So like, why, right? Why does speaking another language make you, because you realize immediately when you speak two languages that there are some things that are very easy to say in one language and very hard to say in another, and there's this whole concept of translation, right? And what is translation but looking at one thing and trying to explain it in a different way or have a different perspective on the same thing, right? I know you speak more than one language, and this must happen to you all the time, right, when you're thinking in different languages. And I think that's exactly what's going on when you're trying to think of creative new solutions to scientific problems, is you're like, okay, everybody's been looking at it this way, and we've kind of come as far as we can looking at it this way, but what if I come from here, right? And so, going back to the arts, I mean, something like music, it's everyone says music is a language, right? It's a certain way of approaching things. It's a certain way of like realizing there's ways to express things that aren't just words and sentences, that you can get feelings and ideas across in a different way. And I think, in that way, that's what helped me, is that's how you come at problems in new ways, right? So it trains you for that. It trains your mind to think that way, just like speaking another language does.
So I spoke several languages kind of growing up.
Yes, you do speak several.
But, I also was, drawing from a very early age, right? Like, I had, a fine art training, and, that's how I kind of really kept myself busy, and it really helped me express myself. And there was a structure, and I got trained in it, and I spent time with people who really knew how to work and explore in abstract terms. And it wasn't just, say, photorealistic replication. It was how do you paint and as silly as it may sound, like how would you paint happy, or how would you paint busy without painting an object, right? Like, what does that mean to you? And when you look at a kid, or like someone paints it, or like kids painting there, you can clearly see that there's a methodology behind that. And I remember when I started at university, I wanted to go there for fine art, right? And the program did turn out to be what I thought it was, so I'm like, okay, I got to figure out what the hell to do next. And computer science kind of seems like the thing to do because everyone's doing it. But as it became more abstract, I kind of saw the structure, and like it was just almost like it was a groove that I could fit into, and I would see a theorem and I would go, oh, that kind of makes sense, but I couldn't quantify it. I could never say, okay, I draw a picture of a theorem. That wasn't it. But there was something about the way it would fit together. If I took this, corollary and this lemma over here, and I put them together somehow, that they would make a bigger whole. But the wheels for that would already be turning in ways that I can't really express.
Because
right?
you were trained that way as a young person, drawing and learning multiple languages, that you understand that you can fit things together that
right.
don't
So
obviously
I think it
fit.
helped kind of me tremendously.
Yeah,
And
absolutely.
I found math at an abstract level actually a heck of a lot more appealing than just like concretely, like memorizing my times tables. Yeah, that was a pain in the neck. But like when it got more abstract, okay, talk about like, vector bundles and sheaves and category theory and all that stuff. Like I enjoyed that a heck of a lot more in grad school than I ever enjoyed, say like stuff like undergrad and that. And for somehow it made sense because there's something in my brain that just said, oh, there's a groove, and that kind of fit in. I remember when I was trying to explain this, what I was working on to my mom, and her to be a musician. And she's like, oh, okay, so this is how stuff would kind of work, and which kind of shocked me because she's not a mathematician. She's a musician. She has been all her life. And she understood the basics of what I was trying to do, which I completely kind of validates your point, right? She speaks multiple languages, musician, but at an intuitive level, she got the theme.
Yeah, her mind is open to a different way
Yeah.
of seeing things, because it's always been, when you're always speaking different languages, always being creative like this, your mind is open. It's open to seeing things in a different way, or assimilating things that are completely foreign to you into your way of thinking, right?
So amongst your students, I mean, do you see ones that are doing really well who've come from that type of a background, or more diverse that way? I mean, have you seen it in examples?
I mean, it's hard. I mean, that's a hard question to answer, and it's good to have real data. Anecdotally, yes. I mean, if I think about the graduate level, usually, the graduate students that I've worked with over the years, they do tend to come from a wide range of backgrounds, and often, the best ones have all sorts of interesting hobbies, and have been involved in different things. Another one, one of my best graduate students was actually like a fantastic athlete, which, you might think, oh, okay, well, that's not the arts, but, you recognize that, there's a whole thing with being an athlete, which actually is another thing you used to do as well. But it's a certain way of like thinking
I just
about
like the pain. I don't know.
Well,
Made me forget.
Well, you know what it is. You know what he's fantastic at? Optimization. That's what he loves doing.
Really?
Optimizing everything. And if you think about it, and if you're a really good athlete, right? And I think you've done this as well, and you're trying to shave, like, how do I get another 4 seconds off my time? You realize, there's all these little optimizations you can make in your bike ride or your swim. Like a shave a little closer, or breathe one less. You know what I mean? And you're thinking about these optimizations. That's one of the things that he's fantastic at optimizing things. And so, it's interesting that he comes from an athletic background. So you realize that all these other things that you do in your life, arts, athletics, they have ways that they will influence the way you do other things like science, right? Which is exciting.
Is that why you took up marathoning? I had to go there.
No.
Because it was like potato chips and like pop. I remember that.
Well, yeah, I've kind of gone back to that, but
yeah, like you ran
a marathon.
A marathon.
Yeah,
like
that was 6
that was
years.
amazing.
Yeah, well, it was just like, you got to do everything once, right?
So what kind of inspired and compelled you to hurt yourself? You know what? Hats off to, I would not run a marathon.
Have you not done that? No,
I have not. I've never run a marathon.
Really?
I've run plenty of triathlons.
Yeah.
Because I have like little patience to do a lot of one thing.
Yeah.
But it was just like, all right, variety, this thing's over. You go to the next one, and like the variety kind of made my day.
Yes.
And then there's the concept of just hurting yourself for like 26 and a half miles and, coming out with, bleeding at the other end of it from your toes. And it just seems like the savagery of the body. Like what compelled you to do this?
Oh, I don't know. Yeah, I thought this would be a good way to exercise, and let me put it in context. So my brother is an ultra marathoner, so he runs 100-mile marathons. This is 160 kilometer runs, and they take about 24 hours, right? So 2 things. First is like, I'd like to get healthy, Second of all, I had been running. I had done like a half marathon. And third, I saw my brother running these whatever that is, 4 marathons in a row. And I thought, well, anything he can do, I can certainly do at least a quarter of it, to which I, was right, although painfully right. So I don't know. It was a bunch of stupidity. It was fun. I won't do it again, probably. It shaves a lot of time off your weekends, these like 3-hour runs.
It's a commitment, yeah.
It is a commitment. So I'm glad, I have my little medal. It says Leiden Marathon 2013. I still have it. It's very treasure. It's nice to have, but
like you finished, right? I mean, that in
yeah.
itself is like it's a big kind of accomplishment. Did that change? I mean, your way in which you kind of manage your time and scheduling? Because I mean, athletics is such a big part. I mean, for me, I still maintain. I mean, I don't run, triathlons anymore, but I've since started doing different stuff. But just the physicality, there's a certain confidence for me. I go, you know what? If I'm really having a bad day or something, I just get into that. Bang out a bunch of like just heavy weights or something, and just something, the oxygen goes through your brain and your body, and you get yourself to going, well, if I could handle that, then certainly I can handle like anything else.
I think that's part of it, yeah.
Did you get kind of a similar sensation when you kind of took up?
Yeah, I mean, it's an interesting question. It's something I've never thought about ever, but you remember being an undergraduate together, and we just worked so hard, right?
Yeah.
It was hard program, and I do think there's this related thing in athletics about academia in hard things like physics and computer science pushes your brain to the point where you're like, okay, I'm tired, I'd like to give up, and you look and you go, well, no, there's an exam tomorrow, and actually I can't. And athletics is there's a similar thing where your body goes, I'm exhausted.
But it's interesting.
I'd like some potato chips. And you're like, no, you're going to keep running.
Yeah.
You're going to keep running. It's a little bit of mind over matter. So I'd never thought about that before, but it's an interesting point. But
it knows, there's CrossFitters and powerlifters and all this. A lot of them are actually like physicists and astronomers and computer scientists and mathematicians. I mean, they've just got, to your point, I mean, it's interesting you raise that. They've got this structure to it going, well, what can I do to increase my my deadlift by another 10 pounds, and like what kind of change in programming do I have to make? And we'll sit down and write it all out and keep these meticulous logs of stuff.
On the highest level of competition.
Yeah, it's not something you can just kind of feel your way through.
Agreed.
So there certainly seems the quantitative people have applied this type of lifestyle kind of within
absolutely.
there. But when you first told me, okay, marathon, I'm like, good grief, man. I mean, like that's.
I won't do that again.
Kind of world of hurt, right?
Yeah. I didn't realize it when I signed up for it, but I did somewhere, 5 miles from the finish, realize that, I have really booked myself into a world of hurt here. Anyway, it was good. I'm glad I did it. It was a nice, cool but sunny day in the Netherlands that I ran it, and I ran through the Dutch countryside. People threw cheese at you, and they did. I kid you not. And so it was a fun experience.
Yesterday was like Canada, Netherlands. I think like the Solidarity Day or something.
Was it?
Right?
Oh yeah. There's this thing because we
Yeah.
sheltered the Dutch family during World War II.
Yeah, so I thought this was a pretty kind of cool day, right? I mean, I managed to connect with a couple of friends there, and
that's right. You have this. I forgot.
Yeah,
right,
it's this great connection that I've
well.
got over there with a couple of friends, right?
Yeah.
So, cheese and stroopwafels and like tulips and everything that's good about that country. The people, I guess that must be a great place to live too.
It was
right?
a wonderful place. Yeah, I mean, you used to visit all the time. So
yeah, and I mean, I still visit. I mean, I went there for my friend's wedding. I guess it's like a year and a half ago. But I mean, if there would be like one other country I'd probably want to live in, would be there. I like the variety in food here a little bit better, because I mean, as much as I love cheese, I suspect that there's but I absolutely love the Netherlands. I mean, it was a great place to live. But you're back here like permanently now.
Yes.
And you're happy for
yes. Although who knows what sabbatical will bring? Sabbatical, great hope. Maybe I'll go back there. Who knows?
You're thinking of it? Thinking of sabbatical at some point? So.
Yeah, well, sabbatical for me would be in 3 years, and the Netherlands would be a lovely place to go, but have to negotiate all these things, so including with spouses. So
man, parting thoughts. What would you tell the young people if who are kind of listening, and old people alike, about what to do from your perspective?
Stay inspired. Really stay inspired to find out what you want to find out about. The world, the universe, etc. At the end of the day, that's what all of us who are in astrophysics, I think, are trying to do. We're trying to figure out, I loved all the questions you asked. I mean, there are these really big questions that we want to know the answers to. And, we're always making progress towards them. Slow progress, expensive progress. But we're getting there, and we're able to answer so many things now that we weren't able to answer. And, sky's the limit, right? As I talked about the James Webb Telescope coming and these exciting sort of astronomical advances, but this was a great conversation also about artificial intelligence and how these things that are, somewhat outside the sphere of science now are coming into the sphere of science. And when you think about, a future where these things blend, like I said, your son may listen to this podcast in the future and laugh that all of the stuff that we were really worried about now got solved, and that there's bigger, even more exciting problems out there to solve. So, I hope your listeners just, stay inspired and pursue what they want to pursue and learn about this universe and stay true to that. It would be a great future if everybody did that.
Professor Adam Muzzin, thank you for coming by and inspiring us and telling us to dream and stay inspired.
Awesome. Thank you. It was
Cheers,
great to be
man.
here.
Thank you.